welcome everyone to today's Synergist webinar, FR8R Myths and Misconceptions and some do's and don'ts about flame-resistant and arc-rated clothing. I'm Kay Bechtold, Managing Editor of The Synergist, the magazine of AIHA. I'd like to thank all of our attendees for joining us today, and especially Bulwark for sponsoring this webinar. I'd like to extend a warm welcome back to today's speaker, Derek Singh. Derek has been involved with the flame-resistant clothing industry in a variety of roles for over 25 years. He has worked directly with end users, developing and implementing flame-resistant clothing programs specific to the customer's hazards, and he has worked closely with Fortune 1000 companies to educate them on the various fabrics, FR technologies, and the dynamics of arc flash and flash fire hazards as they look to develop FR clothing programs. Derek has developed and conducted over 250 educational and informational seminars in the U.S. and internationally. In his current position as Technical Training Manager, Derek has developed over 40 hours of training curriculum for Bulwark University. He is a recognized subject matter expert, qualified safety sales professional, certified environmental health and safety professional, and certified virtual presenter. And now I'll turn the presentation over to Derek.
Okay, thank you very much, and thank you for navigating that pretty extensive bio. My apologies for that. And good morning, good afternoon, live or archived. I want to thank those attending and listening, greatly appreciating taking time out of your valuable day to learn a little bit more about flame-resistant and arc-rated clothing myths and misconceptions. So let's get some of the legalese stuff out of the way. This presentation is for informational purposes only. Customers of Bulwark Protection are solely responsible for conducting their own hazard risk assessment to identify safety hazards in their work environment. Customers of Bulwark Protection are solely responsible for selecting appropriate garments and personal protective equipment for their employees. Employers must ensure wearers use care and maintain their garments and personal protective equipment properly. As working conditions and other factors vary, Bulwark Protection does not make any representation that these garments and personal protective equipment will protect wearers from injury. So, on to the good stuff, why we're here. When we are out in the field and when we're talking to the folks that use our shirts, pants, and coveralls as life-saving pieces of equipment against short-duration thermal exposures like arc flash and flash fire, we come across some misconceptions, some have called urban myths, misunderstanding of the application of the standards and the technology, and honestly, some things that even today are just flat out wrong. And I just want to cover a few of those. There's more than the 10.1 that we have here. But these are some of the most common things that we hear. So if we're still hearing them today, maybe you're hearing them on your job sites, maybe you're hearing them in your facilities, maybe you're hearing them around the lunch table when you're talking about PPE when it comes to clothing. So we'll go through these, and all going well, we'll have a few minutes at the end to take some questions and explore what may be happening or you may be hearing or you want additional information on. So we hear things like all the time when it comes to terminology. Things are, for example, fire resistant. Well, these aren't fires. They're not fire resistant. These are short duration thermal events, and they're actually correct term for the garments is flame resistant. We'll hear that we wear 8812 garments. Well, 8812 is a fiber blend that really doesn't correlate to anything in our market as far as FR engineering or ultimately FR garments. Flame retardant, that's a good one because a lot of folks misuse that one because flame retardant actually refers to the chemistry that's actually added to a modified acrylic fiber or is added to a finished fabric like a cellulosic like cotton or a cotton-rich blend like 8812 to impart FR engineering and FR properties. Fire rated. This was interesting because back about 4 or 5 years ago, there was actually an underground movement to create a new term for NFPA 2112 compliant garments as being fire rated because they tried to exclude a lot of the testing that goes in to make those garments 2112 compliant and focus on the ASTM 1930, which is the thermal mannequin test, which a lot of people like to see because it's the full-blown mannequin. It's 360 degrees of exposure to a jet-fed fire, and it's pretty cool looking. And they were trying to say, we just need to pass that test and be fire rated. Thankfully, that term has gone by the wayside, but we still see permeations throughout the marketplace when folks talk about and ask for fire rated garments. The other one is kind of interesting, kind of like Xerox copiers and Kleenex being tissue paper. We get terms like cotton Nomex because Nomex is such a common name for FR that they interchange that still in the field, and we get specifications, believe it or not, for cotton Nomex garments. So it's kind of interesting how all those things still permeate. The important thing is we'll get, when it comes to finished products, we'll get, this is the exact same fabric, same test results, but way, way cheaper. What is that statement telling you, and what is that statement you have to be cautious of? Yes, you can have perfectly good fabrics. You can have fabrics that meet all the test criteria. You can have fabrics that have outstanding ATPVs and flash fire performance, and you can assemble it terribly. There's a big part of all the standards when it comes to the construction of actually taking compliant fabrics and turning them into compliant garments is all the findings have to be tested and have to perform. That includes threads, Velcro, zippers, buttons, etc. So I can take a great fabric, put it together with all cheap stuff, drive down the cost, and you can have something that ultimately can perform terribly in the field. So be very, very cautious of same fabric, same test results, because the test results are on the fabric, and someone trying to tell you that they can do it way cheaper because they're cutting corners somewhere. In addition, all I'm saying for this whole slide here is know your supply chain. Know your supply chain for two reasons. One, it's obviously from a chain of custody standpoint, if these garments ultimately end up being used for what we build them for. Remember, we're building garments to be utilized on the worst day on the job site. That means you've been in an arc flash or a flash fire. And do they perform? So we want to have a chain of custody. We want to have 10 years of data. We want to have all the test results. We want to be able to trace that garment from when it was a fabric, what the test results were in the fabric, all the way through the supply chain till it gets to you. Do you have that capability? Is your supply chain using proven products that are developed for your hazard and implemented accordingly? One of the things that we have an interesting dialogue, both internally in our building and when we get out into the field, is what is the real hazard? If I asked a group of safety professionals who utilize our clothing for flash fire and arc flash protection, typically the answer we're going to get is arc flash and flash fire. Makes absolute sense. Well, arc flashes and flash fires in and of themselves are dangerous, but they don't get typically hot enough and last long enough to ultimately cause what we're looking to first and foremost prevent, and that's fatality. We get to fatality through catastrophic body burn. We're looking to mitigate injuries. So even if we had an unclothed worker who was exposed to arc flash and flash fires, we're only typically getting a small percentage of that body exposed, typically 50% or less, which ultimately is not going to result in fatality. So when we look at what the real hazard is, what are we really preventing against? So when we say, what is the hazard? Most folks would ask arc flash and flash fire. Is it really no? What we're looking to prevent and what the real hazard is, clothing ignition. Catching fire and continuing to burn is what the real hazard is when we're up against these short duration thermal exposures like arc flash and flash fire. So you can then take and kind of have an interesting discussion. This is not the hierarchy of safety per se. It's using some of the terminology, but we're linking it to what the real hazard is. Can we eliminate the hazard? Well, if the hazard is clothing ignition, yes, we can eliminate it by eliminating clothing that can catch fire during a short duration thermal event. We can substitute cotton fuel with fabrics that won't ignite and continue to burn. Can we apply engineering controls? We can utilize science to remove the combustion properties of fibers and fabrics by implementing change in the molecular, fiber, or the fabric level. Can we have administrative controls? Obviously, training on the proper selection, use, care, and maintenance can apply admin controls to this hazard. And then obviously the PPE is the PPE, and what does it do? It self-extinguishes when the ignition source has been removed. So it's just a different way to look at and have a discussion with your folks on what the real hazard is. And the real hazard is being clothing catching fire and continuing to burn. Big complaints about flame-resistant arc-rated clothing. What are the top 3 problems that have permeated and still radiate and are still talked about in the marketplace today? Well, it's easy. They're too hot, it's heavy and uncomfortable, and they don't fit well. Well, what does that happen to then when we have pushback as a safety professional and our team is pushing back on this topic? What are some of the things that we find that unfortunately how they respond? Well, they can just put it on when they need it. That's probably the most common response that we get from folks when there's pushback in the field. And especially from an electrical standpoint, we're not going to wear this every day, all day. We're just going to utilize this when we are doing energized tasks. And we'll just put it on when we need it. Unfortunately, by doing so, you actually exacerbate the top 3 reasons why people don't want to wear flame-resistant arc-rated clothing. In fact, by doing these 3, you're putting on typically a 7-ounce or a 9-ounce coverall out of your quote-unquote hot kit. You're putting that over top of your industrial-level cotton garments already, because at the very least, in an industrial environment, you're not wearing 65-35, you're wearing industrial cotton. So you're putting a 7-ounce, 9-ounce arc-rated coverall over top of your 100% cotton work clothing. You're adding additional cumbersome layer, and you're also wearing what arguably is an ill-fitting garment in a coverall because they're not designed to be form-fitting. So by default, you've in fact reinforced the top 3 problems. So how do we combat that? Well, thankfully today, where we are in the marketplace, and as we talk a little bit more down the line, we have lightweight, air permeably, moisture wicking fabrics that are constructed into shirts, pants, and are able to provide a daily wear component to where we don't have to get in and out. And these garments are at retail weight, very, very similar to what you're purchasing in a non-FR world, and they can provide equal to or greater protection than they have in the past. Continuing on with it's too hot, how do we encourage compliance when it's hot? If I work in a naturally hot environment, aka inside my facility, it's naturally hot because what we're doing, or we happen to work outdoors during summer months, which are extending from March now to September, October, where they can be ambient air temperatures easily over 80 degrees, and in some cases hotter. How do we work through this number 1 complaint? The easy answer, or the short answer, is wear trials and training. Wear trials. Get the latest, greatest examples of the FR technology and arc-rated technology that's going to work for your hazard on your people's backs, and have them try them out in the environment that are going to utilize them. And all the top providers today are more than happy to provide those kind of wear tests. And in addition, educate folks as far as what is perception and what ultimately ends up being the reality. And the reality is there is no adjustment factor for single layer, nominal weight, work clothing type layers for heat. It's just not there. Heat is shed primarily by the evaporation of sweat. And even though any kind of shirt, pant, configuration is going to be a barrier to that, there are some properties that can be enhanced in the fiber matrix to mimic the body's evaporatory cooling system, We can look at air permeability. We can look at weight as one factor. And then more importantly, we can look at moisture wicking, getting that moisture off your body to the outermost layer and aiding in or mimicking that evaporation. As I said, there is no adjustment factor for work clothes, long sleeve and pants, or woven material coveralls, whether it's FR or non-FR. And today's fabrics are, even now, we're looking at shirt weights that are what we are calling sub 6 ounces, which is pretty much identical to retail weights when it comes to above the waist. We usually, from a marketplace standpoint, don't see much pushback from the waist down. People are pretty comfortable because non-FR denim has been in the 12 to 14 ounce weight range for a long period of time, and we don't typically see pushback when it comes to from the waist down. We see pushback, aka correlating that to comfortable or uncomfortable or hot at the shirt level. So as we reduce the weight and we incorporate additional factors into it, and we'll talk about that shortly, we can get to that sweet spot, so to speak, as we look at improving against the pushback that FR/AR garments are too hot. So as we expand this from a cautionary standpoint, we talk about lighter is more comfortable, and we want to push a little bit back against that. We don't want to look at marketing materials or brochures or make decisions about what to wear across a desk. And what I mean by that is picking up one garment and over another and saying this one's lighter, it's going to be more comfortable. That doesn't correlate. And I want to suggest next time you have a meeting and you have folks in a room and that collection of people is going to be, let's say it's over 10 people. Let's say you have 15, 20 people in the room. Just make a quick observation, and what you'll see on average is you'll see people in short sleeves, short sleeve polos. You'll see people in long sleeves. You'll see a t-shirt with a long sleeve over top of it. You might see a hoodie, a sweatshirt, a lightweight jacket, a vest over top of a long sleeve. The bottom line is whatever combination of clothing that you can think of, you will probably see something close to that represented in your next group meeting. And the point is most people don't show up to be uncomfortable. They're probably sitting in an ambient air temperature of 68 to 72 degrees, and what they're wearing in their mind makes them comfortable. So layering, length of sleeves, fabric weight in and of itself is not a determinator of comfort. Comfort is purely subjective to the wearer. So what are factors that we can look at to where we can enhance and complement, aka be more comfortable? Well, you want to have high air permeability, but that in and of itself is not a distinguishing factor to comfort. What you want to have is moisture wicking. You want to mimic the removal of moisture from your body and help get that off. So as you look at that balance, you want to have wicking properties, you want to have air movement, and you do want to have weight to a certain degree factored in. I don't want to have a 9 ounce when I can be in a 6.5 and have all these additional factors to it. So as I look at clothing, I want to have wicking as part of the fiber, not a finish, because remember, all finishes are going to wash out at some point. So I want to have wicking in the fiber matrix. I want to have something that's going to absorb moisture off my body. I want to have air permeability, so I want to have the FR engineering sophisticated enough that it doesn't have to be tightly woven to get to the protection values needed. It's going to be opened up so air can move through. And then I want to have it at a reasonable weight so it's still going to insulate me against what? The short duration thermal exposure that I have to protect myself against. Because first and foremost, on our side of the fence, we have to protect you first. We have to achieve a certain arc rating that you're going to desire to utilize it in. And we have to be NFPA 21 compliant from a flash fire short duration thermal exposure for our oil and gas refinery and chemical facilities that have that hazard. So protection first, and then we're going to factor into this. So lighter in and of itself is not necessarily more comfortable. FR is way too expensive. Well, one of the things we want to caution against as we think about what goes into making that piece of PPE is what happens when we look at PPE strictly from a cost perspective or from a low cost perspective. There's chances that you may be eliminating safety from that selection process. If it purely becomes a commodity decision and we have driven down or lost perspective on the value of what the PPE does, could we possibly be taking safety out of the equation? From an innovation standpoint, are you going to get the lightest, most comfortable with the best technology at the lowest price? Highly unlikely. Safety program, selecting FR and AR garments strictly on price. Could you possibly be sending the wrong message to your team? Low cost often comes with durability issues, potentially poor quality issues. When are you going to find out where those corners were cut? Unfortunately, in this garment, under these short duration thermal conditions, you'll find out where the corners are cut during probably post event. How much injury have you received that you should not or did not need to receive because of the poor quality and the FR durability questions? You won't find out until it's too late. It's going to be unlikely that a single supplier can be across all your product needs to be the low cost. So you're going to spend a lot of time researching and manipulating different supply angles and supply chains there, potentially increasing the cost. Purchasing flame resistant arc lights solely on price creates a transactional relationship, which is very difficult for the supply chain to get you the most beneficial products via your relationship over time. They're always going to be kind of playing from behind the curve, so to speak, and every chance is potential chance for losing the business, or you're most likely going to get the best of everything. And then the real danger is just what I alluded to earlier. Where are those cost savings going to come into? Well, we're all working within the same resources, so you're going to get, if it's dramatically if it's dramatically lower than say what the mean average is for a shirt, pant, or coverall. Why is that? What were they able to manipulate that others weren't in order to get to that low price leader? So you want to be careful that way. And then lastly, is too expensive compared to what? Too expensive compared to more injury. When you look at what you're looking to protect against, and that's burn injury, how much additional injury are you willing to receive from a lower quality product than you were from the higher quality product? Are you willing to receive an extra 5 to 10%? Because that's ultimately what you're making that decision on. And if you're looking for an extra day and a half per every percent body burn, that's an extra 10 to 15 days in a burn unit at $25,000 a day. Can you get enough cost savings over your program to justify just one additional day in a burn unit, fare less 10 additional days at $250,000? It's easy to make the cost justification after what you should have done after the fact. It's difficult to do in the fact that your insurance policy, your mitigation of these types of costs are going to be in line with the overall goal of your program. So we are always trying to help folks understand that part of this is your insurance for if anything goes wrong. If nothing goes wrong, yes, you may have perceivably paid more than you should have, but if you do have an event, you are mitigating or minimizing those overall costs at the end of the day. Does it work? I mean, believe it or not, we get questions and we get pushback saying we don't really need it. It's overkill. We're paying way too much for the technology. We've never had an incident here. And how can it really protect? And what do we need to do? Well, first and foremost, when you look at the burn data, and this is from the American Burn Association 2000 to 2009, The green bar is less than 25% body burn. The yellow bar is less than 50% body burn. The red bar is greater than 75% body burn. And you can see, obviously, it indicates age is a major factor in how you recuperate, how you recover, how you respond to catastrophic injury. We're nowhere near as capable at 50 as we once were at 25. That's one way to look at the graph. The other way to look at the graph is if I am wearing my flame resistant arc rated shirt and pant correctly, can I have greater than 25% of my body exposed, even if it were to break open or exceed the protection values because I've miscalculated or I've been in longer or for whatever myriad of cases where I may be a little bit more injured than what I have exposed. With flame-resistant arc-rated clothing implemented properly, it's hard to get greater than 25% body burn. Just think about that. That's a quarter of your body has been injured. And what the graph tells us is anything less than that 25%, across all age categories, it's almost 100% recoverable from. It's 100% survivable at proper implementation. And you can look at yellow and you can look at red as far as not having it or having it and wearing it incorrectly, and I'm incurring more injury than I could have. But the takeaway is if I'm wearing it correctly, there's not 25% of me exposed. And secondly, if there's not 25% of me exposed, I'm not going to have more than 25% injured. So hence, does it work? Yes, if I can keep your body burn percentage under 25% across all age categories, it's basically 100% survivable. So yes, it does work. Does it matter what I wear under my flame-resistant clothing? And a lot of folks perception is that this stuff on the outside, this shirt, pant, or coverall, is invincible. I am Superman. I can walk into burning buildings and there's nothing going to harm me. That's not the case. You're looking at 7 ounces, you're looking at 9 ounces, you're looking at shirt weight and pant weight, and the only thing they will do is self-extinguish once that ignition source is gone. They are not a suit of armor. You are not impervious to injury. So there are some things you have to factor into the safety system. And that ensemble includes what you're wearing underneath. One of the biggest parts when we're out in the field training is educating wearers who may be new to a program, may be coming into a program and not been in FRAR before, or adopting FRAR for the first time, is we have to educate them that all they're allowed or all they can wear underneath that garment is natural fibers. Now, for the most part, that's easy. That's cotton t-shirts. That's something like a wool insulating layer during the winter months. Even silk as a natural fiber can be utilized underneath there. Why? Because they won't melt, drip, and add to the injury. The downside to that whole determination is when we look, especially with our cotton t-shirts, and you can see where that V is at the neckline. If I'm a safety director and I look at my team and I see nothing but white V's, am I 100% confident those are all 100% cotton? Am I 100% confident that there's not a whole bunch of big logos sitting underneath that top layer that I cannot see that is made of inks that may melt and add to the injury if they're in an arc flash or a flash fire? I don't. There's no confirmation that those are all 100% cotton just by looking at them. So there is an inherent weakness in that program, even though you've educated, told people. My observation is, as I see white cotton, there's 100% cotton, there's 80-20, there's 50-50, there's 60-40, and probably a myriad of other ratios that you could be introducing irrelevantly or unknowingly meltables into your program. So one of the ways that we can eliminate that is introducing flame-resistant arc-rated base layers, because what do is they protect against, especially in our electric arc world, that outer layer failing. For example, if I have a piece of equipment that I have been told a reasonable estimate on that piece of equipment, if it is an arcing fault, will be 5 calories of incident energy. If I'm wearing an 8-calorie shirt, I'm confident that I've got more than enough protection and insulation for that 5-calorie exposure. Now, that 5-calorie exposure is typically at 18 inches, and that typically is going to be, say, 2 to 4 cycles of closing time, depending on the equipment. Well, if I'm a little bit closer and that equipment decides to close in 8 cycles instead of the 2 to 4 that it was calculated at, could I be exposed to greater incident energies than expected? Yes, you can. Can that outer layer start to fail? Yes, it can. What's underneath now may potentially contribute to injury by what? If it's cotton, it's latent fuel. Is there enough incident energy after breaking the outer layer open to potentially cause ignition? We have seen it. So how do we eliminate that? The next layer underneath also has FRAL properties, and we take that out of the equation. Being the underwear police, not just for that 80-20 and 50-50 cotton combination, but what about performance fabrics? What about athletic performance fabrics that folks are wearing in hot environments where they're sweating, and they want to bring those attributes to their workplace, and they mistakenly, because they either choose to ignore it, haven't been trained on it, they wear that meltable, that 100% lightweight synthetic underneath their garment. Could that factor into injury? Absolutely, because all that energy is still passing through that outer layer. It hits that lightweight 100% polyester, it liquefies it, and if it happens to be an arc flash, I've also got 2,200 square foot pounds of concussive force driving that molten plastic into my skin. And you can see scars like that we see on that lower right there that can occur in folks that make that decision. So eliminating fuels and meltables is an absolute must. Having an additional flame resistant arc rate would be taking that from good, better to that best level, taking all that out of the equation. FR vests and Raingear are enough. And what do I mean by that? There are vests and rain gear out in the marketplace today designated as FR. And they are being marketed to our oil and gas community and our electrical community. And unfortunately, they're being misappropriated and applied because they are misunderstanding or not following through on reading how they determine to be FR. There are standards out there that allow manufacturers to claim FR properties that are not a performance standard, and they're not an indicator of how that garment will perform in an arc flash or flash fire. ASTM 2302 in and of itself is a standard that talks to heat resistance and flame resistance, but does not, as a standalone, indicate arc rating or flash fire protection. Combined with other standards, it can, but as a standalone, if that's the only standard reference in that label, it's not to be used in a flash fire or flash environment. Additionally, ASTM 6413, we see a lot, especially when it comes to high-vis 100% polyester vests that are marketed as FR. That is not a performance standard. That is the vertical flame standard. It is utilized for fabric evaluations all across our space, but as a standalone by itself gives you zero indication of how that will perform in an arc flash or a flash fire. If that's the only standard you can see in a label, you're jeopardizing your FRAR clothing program, because this is now sitting on top of that, and it may nullify your whole investment in your shirts, pants, and coveralls by having the wrong vest. NFPA 701, thankfully, we don't see a lot of anymore. That wasn't even a garment standard. It was it's a drapery and linen standard, primarily for the hospitality industry, and it was misused, again, for rain gear and vests for many years. But if you have some older inventory and you see that one on there, that again is not designed for your hazard. So what is designed for your hazard? Typically for vests, we're going to see ASTM 1506 and an ARC rating in that label for your vests, or you're going to see NFPA 2112 compliant for a vest. For our rain gear, we want to see ASTM 1891 for ARC, and we want to see ASTM 2733 for flash, or both. Ideally, both. You don't have to make any decisions if you have both hazards on your facility, but if you're a utility or if you're a refinery, make sure you're utilizing Raingear that has the correct standard. Here's an example of what you may see that has caused some of this confusion. How much misleading information can you get on one label? So at the top, as you read this, there's a couple of indicators that would lead me away from this particular garment immediately. 100% polyester treated. That is not anything that I want to have on my job site if I am in a arc flash or a flash fire hazard area there. Self-extinguishing per ASTM 6413. This is an example of just one standard claiming for it to be FR. On the lower left, you'll see that they created their own terminology, self-extinguishing as in SE. Even though that's what the test does, there is no adoption of the term self-extinguishing in our particular space in the marketplace for flame-resistant arc-rated PPE. Yes, it's an attribute of the actual test, but there's no adoption as SE as far as it carrying any weight. So it's not a performance standard. It's not one of the standards that is allowed by ANSI 10715. It has correctly named itself as non-FR, which is a requirement, thankfully, of ANSI 107-15. But then if you read on the lower right, it goes back to claiming that it's FR. So is it non-FR or is it FR? That is a lot of misinformation on one label. And they're out there and they're on job sites and they are in facilities today because we don't see them all the time, but we see them enough of the time that it is concerning. So what should we have on our high-vis safety apparel? If you have ANSI compliant safety apparel, ANSI's done a great job in the 2015 version of laying out there are 6 standards that you are allowed to meet and claim that you have FR properties in that high-vis vest or that high-vis rain gear. A number of them we just stated on the previous slide: ASTM 1506, ASTM 2733, NFPA 2112. NFPA 1977 is on there. We don't see a lot of those in the marketplace because that's the wildland standard. 2302 was reintroduced and specifically states that it cannot exist in and of itself to represent FR properties. It must have one of these other accompanying standards. And if none of those are met, they have to announce and tell you this garment is not flame resistant as defined by ANSI 107-2015 section 10.5 on the label. And that's what those labels look like. So if you want to do a quick check of your tool room, a quick check of your last procurement list and take a note of that, just some caution there. In our flash fire environment, we always get asked, please get me the garments with the lowest body burn. And how do we get that? They're going to ask the representative of the garments to produce the ASTM 1930 test data so that they can ensure that they have the lowest burn percentage so that they can tell their team that they have procured garments with the lowest body burn percentage. Unfortunately, for a couple things, the lab is designed to test fabrics. It's not a performance test for garments. In fact, those coveralls that go on that test mannequin are single layer. They're not commercial grade. There's no additional layers of chest pockets, rear pant pockets. If this is a test, for example, if you're wearing denim and shirts in the field, you can't extrapolate one over the other. The bottom line is they are a test protocol for the fabric manufacturers for pass and fail to determine whether or not to continue testing that fabric and ultimately build garments out of that fabric. It's 2112. It's for us how to build it. It's a 3-second burn. It's a jet-fed fuel fire. It's 360 degrees exposure, and we have to have less than 50% predicted body burn. It is a great test under very extreme conditions, and what I want you to think about and what I'm going to show you in the real world is if it is doing that in the lab, is very, very good indicator of you're going to be mitigating a lot of injury in the real world. Because why? In the real world, these vapor clouds tend to be rapid moving flame fronts. They're fuel dependent, so that consumption of that fuel is rapid. They're directional from the ignition source back to wherever the leak was occurring. And it is a completely different dynamic than what we see in the laboratory. Also, when we look at ASTM 1930 test data to choose FR clothing, it's important to understand the difference between what's happening in that laboratory with single layer non-commercial garments. We don't want to take those results and look at one fabric weight versus another fabric weight and determine that because one has a lower body burn percentage in this particular test, that that's going to be the best solution for my folks in the field. In the annex in 2112, they even caution you and they want you to understand that that test methodology was never designed to be utilized as a purchase specification. And very, very few reps out in the field are going to communicate that to you because they're more than happy for you to purchase whatever you think is best for you. And if it's solely based on the body burn percentage and they have that fabric and they have that garment, they're more than happy to help you do that. But is it the best garment for your facility? And here's what it looks like as best as I can represent here without showing you the video on this platform. So what you see here is an accumulation of, in this particular place, the hydrocarbon is propane. The ignition source is sitting just off to the left of the screen there. You can see it as it's circled. The fuel is making its way directionally towards that ignition source. What you're going to see is in the first tenths of a second, we're literally 2/10 of a second into that event, it has been ignited and it's already making its way as a directional force towards the right of the screen. It's moved away from the ignition source, and that rapid moving flame front is going back towards the wellhead in this particular case. In the next slide, we're talking about 1.8 seconds and change later. It has gone the 40 feet that slide, that scene takes up. There is no more thermal energy. The thermal energy you see in the lower left was the flaring from the initial thing that caused the ignition, and that rapid moving flame front is already off the screen. And what I share that with you is to think about, okay, if my test methodology is 3 seconds exposure and this whole event is 2.06 seconds, is there 3 seconds of exposure at any single point in time? The answer is no. It's a directional flame front. You can see that moves rapidly from gaseous diffuse fuel to ignited cloud to rapid moving flame front off the screen. Is it 360 degrees exposure? The answer is no. As we factor all that together, and let's say I presented you with two fabrics. One fabric had 32% body burn under those laboratory conditions. One fabric had 14% body burn under those laboratory conditions. If you were looking for, quote unquote, the best body burn, you would choose 14%. Now, if I told you that one fabric was 6 ounces and one fabric was 9 ounces, and you were working in Louisiana in July where it's 9 degrees and 9% humidity, one was 6 ounces at 32% and one was 9 ounces at 14%, do you still want to make the same decision? Well, that's a hard sell when it comes to I'm using this as my only evaluation. But if you factor that back into the scenario I showed you on the previous slide, if it's not 3 seconds, it's not going to be 32% body burn. If it's not 360 degrees, it's not going to be 32% body burn. What is the percentage of body burn when I start adding chest pockets, rear pockets, front pockets, pocket bags, all this additional FR layering, what's the real percentage bodies burned, can't be determined based on the information that you have here today. But is it reasonable to think it's going to be dramatically less than that? So could I make the case for having, quote unquote, 32% body burn utilized for my flame resistant clothing in this particular case? Understanding the test methodology versus the real world, understanding a commercially viable garment versus a test garment, you can definitely make that discussion at the very, very least. On our electrical front, cotton works just fine. Believe it or not, as far and as deep as we are into NFPA 70E, the fact that we're 21 years into when the actual standard first came out talking about flame resistant garments when doing energized tasks, we still have pockets to where cotton is fine for my electricians because it's a safety upgrade. It will not melt or drip. The part that they fail to talk about is up until the point it ignites. Once it ignites, it's definitely contributing to injury. So my apologies here. This is a video. And in this video, which won't play on our format today, is we have a relatively low incident energy. You have 4 calories per centimeter squared. When that piece of electrical equipment faults, you see ablation of the outermost layer, which means it's actually blown away, and you have instantaneous clothing ignition, which begins to include the arms. It begins to work its way around the back, and you can see how we go to very significant injury in a relatively short period of time. So 70E from the clothing standpoint was written to prevent what? Wearing fuel into an ignition source. The ignition source is your 200 amp disconnect, your 480 panel, your energized task of voltage testing, troubleshooting, or verifying for lack of voltage so you can work on it de-energized. That's your ignition source. The fuel that you wore is actually that 100% latent fuel, aka cotton, sitting in front of the ignition source. The ignition is absolutely instantaneous, and there's areas of the body being injured from that clothing ignition that was never exposed to the short duration arc flash. The other piece of that puzzle when it comes to PPE and what the arc flash studies tell an electrician is how big a bomb you're actually sitting in front of, because it'd be very, very good information to know if the incident energy is 5 calories or the incident energy is 25 calories. Completely different exposures, completely different set of PPE, simplifying one's Cat 2, simplifying one's Cat 3. One's going to be very, very similar to the moon suit that we are all commonly see in the workplace, and the other one is a shirt, pant, or coverall. I would like to know that. Unfortunately, without the arc flash study being done and without the labeling being done, unless I'm educated on 70E and I can utilize the tables, or I utilize the simplified two-step approach as in Annex H, I am not going to know how to dress in front of that so that I'm protected. So we want to tell our electricians how big a bomb they're standing in front of so they can dress accordingly. The other piece is, and I see this more often than I would like, it still permeates through our industrial complexes, is we'll just throw on a flame-resistant arc-rated lab coat because it's made of fabrics that actually have an arc rating, and I can just do that temporarily because that'll be my task-based solution. My electricians will get to wear their cotton. They won't be displeased with me enforcing a flame-resistant arc-rated clothing program, and I'll just have an inventory of quote-unquote lab coats that they can doff to go do these energized tasks. At no place, anywhere in NFPA 70E under any of the selection methods for flame resistant and arc rated clothing, are you allowed, or does it even mention that you can utilize a lab coat? The only place that a lab coat should be utilized is in the exact description title of the garment. It is a lab coat. Though these fabrics may have the same arc ratings as shirts, pants, and coveralls because they're being utilized, the design of the actual garment does not allow for it to be used in a arc rated where you need protection from an arc flash. The design itself has a huge opening in and around the neck area where if I had fuel sitting underneath, aka my 100% cotton work clothing, where do you think that arc typically, and where's all that heat and energy going to go? Right in and around in that chest area. At the bottom, it's wide open. If we happen to have an arc, and arcs are unpredictable, yes, I just said there's a good chance they'll hit you in the chip, but what if it goes rocketing down to the floor, mushrooms out at my feet, and all that energy travels up the legs of my 100% cotton, aka candlewick pants? I've just ignited my pants. I've just ignited myself from the ankles on up. Is that coat even going close to have protected me? It is not expected to be utilized in that manner. It's not talked about or allowed to be utilized in that manner. Any descriptor within 70E talks about long sleeve shirt, pants, and or coveralls. Long sleeve shirt, pants, or coveralls, or arc flash suits. That's your options. Taking it into the fabric thing, we still get terms like inherent and treated. In fact, if I go out and talk to 10 people and I ask them to raise their hands and say, have you had flame resistant arc rated clothing at your facility? Have you talked to anybody, or have you been on a webinar in the last 6 to 8 months? And if their hands go up, yes, and I ask them to turn, are you heard the term inherent and treated? Absolutely. And everybody understands, yes, inherent is better than treated because that's what it's designed to do. It's designed to implement doubt. It was a marketing campaign way back in the 1980s, early 90s, when durable FR cottons were first coming into the marketplace. The marketing push against those is to impart doubt in those fabrics and their performance, because prior to that, inherent and treated did not exist. So 30 years ago, these terms came out. So my question is not so much the validity of the terms, but are they even accurate today, 30 years later? Because the common understanding, or for this discussion, misunderstanding of the terms are: one, inherent. There's nothing inherently flame resistant on this planet except asbestos. If it is claimed to be inherent, someone, whether they changed the molecular formula or they added a fire retardant chemistry to the soup before it was extruded as a fiber, those are man-made. Humans got involved to impart FR properties into a fiber that prior to was not FR, aka it was not inherent. Better performance. How do we judge performance? Why is it better? And then lastly, how it's laundered doesn't matter. Well, if I add a whole bunch of bleach over time to a synthetic, I'm going to weaken those fibers and degrade its performance. So yes, I can mess it up, as I can any FR fabric, by not laundering it properly. On the treated side, the term is it's chemically dependent. Well, they do use FR chemistry to impart the FR properties. That's not entirely inaccurate, but it's surface and topical. That's not true. In fact, the process is very sophisticated. It has to be done properly in order to get that bond with that cellulosic, so it is durable to launderings and durable to normal wear and tear. So the last piece is launderings affect the FR properties. All FR properties and all FR engineering can be messed with if we don't care for it. That's why all FR garments have, this is guaranteed for the life of the garment, assuming proper care and maintenance. And the reason I bring that up is because in today's world and what you're faced with as decision makers and evaluators, you'll see new fiber complexes all the time. You may have natural fibers that provide moisture wicking. You may have natural fibers that have FR engineering in them. You may have synthetic fibers that may or may not have FR engineering. My point being, the 12% nylon and an 8812 blend does not have any FR engineering, where you're going to have para-aramids and aramids that are synthetics that have been molecularly altered that have FR engineering. Whether those are running north or south or east or west, we're trying to capture all the pros of all the fibers to give you the best fabric. But my question is, knowing all that, what do I call this? Is it inherent or treated? Is there a certain amount of synthetic FR fibers that I have to call it inherent? Is there a certain amount of non-FR fibers to where we have a treat? The bottom line is there are no rules. What we want to look at overall is what is the FR engineering, and more importantly, how the FR engineering is applied. And for you, the wearer, is that FR engineering guaranteed for the life of the garment? And that's really ultimately what's important, because there's three primary ways that we can get FR engineering. Molecular level, I talked about Nomex, Curwell, Twarons, Kevlars. We tweak the molecular bond to where it won't support combustion. The fiber level, I add a whole bunch of fire retardant into that, and the fibers don't support combustion. And then obviously the fabric level, where we actually adhere to the cellulosic component and we're FR durable. All of these, at the end of the day, are they going to protect me day one, day 1001, and more importantly, the day we need it? So as we're wrapping up here, I notice that we're getting pretty tight on time. I'm going to deal with this last one, then we're going to kick right to some questions. The toughest piece we have in the marketplace is task-based versus daily wear. Task-based, I am knowingly going into a thermal event, aka I'm a firefighter. I have a structural fire, I'm wearing my turnout gear, and I go into that burning building and I squash that fire. I go back to the station house, I'm not wearing all that PPE again until the next time the siren or the klaxon goes off. In our world, because these are accidental events, we have to be wearing a level of protection at all times. We have to have a base layer of protection at all times, because believe it or not, we don't build our industrial equipment to explode, whether that's an arcing fault or whether that's a hydrocarbon on one of our facilities or a chemical reaction. We don't have time to go get it. We're not knowingly going into a thermal event, so we don't have time to don it. We want to have that base level at all times. So there's a few slides here left over. I'm going to cut right to the end because we're right up on the bonus, which is COVID-19 stuff, which I'm sure everybody's exhausted about anyways. So let's pass it back to Kay and let's handle a couple of questions. If we don't get to your question, I will get a report, and I promise you I will get you your answers after the fact. Thank you.
Okay, great. Thanks, Derek. The first question, excuse me, I have comes from Celia, who asks, do your FR/AR base layers for women include bras?
So great question. We have to be very, very cautious. We at Bulwark, we do not manufacture FR bras. There are some providers out there that when I get your information, I'll be more than happy to provide you with who do that, because we have to be cautious with our female workers who are in and around this hazard. We don't want any of their undergarments to contain any metals or any meltables. And there are a few options out there. Dry Fire is one of them. NSA is another provider. So there are solutions to eliminating those potential contributors to injury for our female workers.
Okay, great. Thank you, Derek. Unfortunately, that's all the time we have for today. Like Derek mentioned, we provide a report over to him, so he'll be able to address any others that we did not get to. I wanted to thank Derek Singh for his presentation and thank Bulwark for sponsoring today's webinar and all of our participants. We appreciate you joining us for the last Synergist webinar of 2021. I hope everyone has a safe and healthy holiday season, and we look forward to new Synergist webinars in 2022. Thanks to everyone again, and have a great day.
This concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv, and we will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.